Hello and welcome to Lab 5, the Human Rocket, with Joseph Naum. My question today is, what is an appropriate model for air resistance in Felix's jump? I found that before the release of the parachute, drag force was equal to 1/2 times 55, the drag constant, times v squared. And with the parachute, the drag force was 1/2 times 64 v squared. The main concepts in this problem revolve around Newton's second law. Newton's second law states that net force is equal to mass times acceleration. The net force equation in this scenario is the gravity force plus the drag force. Now the drag force would oppose the direction of motion, and its equation is 1/2 times the drag constant times v squared. Whereas the gravity force heading in the downwards direction would be equal to mass times gravity. Felix's mass in this scenario was 117.934 kilograms with the suit and his body. G is obviously equal to 9.8 meters per second squared, and I found that B initial was 55 and that B with the parachute was 64. Now for the code. This was initializing the initial values that I needed to set the conditions for his jump. So I set the mass equal to 117, and he jumped from a height of 36,575 meters, which I divided by a factor of 2 so that the numbers were easier for visualizing. Now we get to the main calculation. This part of the while loop calculates his position and velocity after releasing the parachute, and I found that he releases parachute at 2,438 meters in the air. However, to make things easier, I divide by 100 again. And as you can see, B is equal to 64. And here is Newton's second law. F net is equal to Fg plus Fd. And this updates the velocity and this updates the position using these equations. Now this is the while loop during free fall. As you can see, the parachute equations and the while loop equations are much the same. The only difference is in the else part of the while loop, it does not change the value of B to 64. Thus, it uses 55 as the drag constant. Was this an accurate model for his motion? Both yes and no. Yes, because my model put Felix at negative 15 meters at the end of his jump, when in reality he should be at 0. But this is pretty close in a large scale. However, his actual motion looked nothing like this. He would have traveled much faster and experienced a much larger drag force from his parachute than I predicted. This model was pretty inaccurate. And here's a printout of his position at 600 seconds. Does this model for air resistance well? Once again, I believe this is a semi-accurate model for the air resistance due to the fact that when he actually jumped, he jumped through changing air densities, and there are many other factors than I accounted for. So essentially, I simplified the scenario so that I could work with it. The end.